Okay, so good day. So today we're going to be starting with some additional worded problems for work and energy. So later on, siguro sa kanan natin dadagdag yung power. But for now, we'll be dealing with work and energy. Okay, so I have prepared 4 worded problems and hopefully everyone will understand this recording. Okay, so let's start. So the first problem is question number 1. A 28 kilogram child slides down a playground slide from a height of 3 meters above the bottom of the slide. If her speed at the bottom is 2.5 meters per second, how much energy is lost to friction? So dito ang nahanap natin is the energy that is lost. So the problem here is quite simple. So we have a slide and this child slides down from a height of 3 meters and at the end of the slide, so let's add to the slide, the end of the slide, it is found that the child has a velocity of 2.5 meters per second. Height of 3 meters. Okay, so obviously at the beginning of the slide, there is no velocity yet. Wala pa siyang bilis kasi magsisimula pa lang siya bumilis. So at the start of the slide, meron siyang gravitational potential energy. At the bottom of the slide, where we will assume that this is the 0 point. So at the 0 point, wala na siyang gravity. Okay? So wala na siyang gravity, meaning wala na siyang height. So meaning wala na siyang gravitational potential energy. So purely kinetic energy na lang ang meron siya. Okay? So to solve this problem, we could do this by adding work. Okay? So what is the work done on the system? So the work done on the system, there's only one force, walang iba. Okay? Isang force lang, which is force of friction, which is outside of the body. So yung friction, the work done by friction ang meron tayo, which is equal to the change in gravitational potential energy plus the change in kinetic energy. So the work done by friction, this is the change in gravitational potential energy, which is at this point, this is from initial gravitational potential energy, from final minus initial, plus the change in kinetic energy final minus kinetic energy initial. Okay. Or this is the change in gravitational potential energy at may change in kinetic energy. But the final gravitational potential energy is 0. So wala siyang gravitational potential energy. At the bottom, wala naman siyang at the start, wala naman siyang kinetic energy. So 0 din ito. So meaning it's just kinetic energy final minus PEG or gravitational potential energy initial. So that means that we have kinetic energy final minus gravitational potential energy initial. So that means that is kinetic energy final is 1/2 mv squared minus gravitational potential energy, mass times gravity times height, initial height, which is 3 meters. So here, we cannot cancel mass. Unlike before, nung nagko-convert tayo ng energy, we cannot cancel mass because on the other side, meron tayong friction. Okay? Meron tayo ditong frictional force. Ito yung work done by friction. So, hindi natin pwede i-cancel itong dalawa because merong ginawa si friction sa kanila. So we have to do what is here. So ang given sa problem, the mass of the child, which is 28 kilogram, which we will use later on. We have the initial height, which is 3 meters. The final velocity, which is 2.5 meters squared, meters per second rather, 2.5 meters per second. So hinanap natin is the energy loss through friction. So ang required is the energy due to friction, or the work done by friction. Okay. So the work done by friction, 1/2 mv squared minus mgh. So putting in the values, we have 1/2 mass, which is 28 kilograms, times the final velocity, which is 2.5 meters per second quantity squared, minus mgh, mass 28 kilogram, gravity, of course, acceleration due to gravity, which is 9.8 meters per second square, times initial height, which is 3 meters. So the answer is 735.7 joules. But mind you, there is a negative. Why is there a negative? Because work done by friction. Friction is against motion. So ang motion natin is pababa. Ang direction natin ng motion pababa. But frictional force, pataas ang frictional force. So against motion siya. Most likely, negative ang magiging dulot niyang work. Kaya nga, pabawas yung energy niya. Instead of helping increase the energy, friction decreased the energy. Nag-negative siya. So that's the answer for question number 1. Okay, so we move now to question number 2. So, question number 2. Does it require more energy to stretch a spring from 0 to 10 centimeters than it is to stretch the same spring from 0 to 10 centimeters? So, let's try to analyze that. Ang problem is, meron kang spring that, let's say, it is at this original position, 6. So, this is the original position of the spring. So, we stretch it 1, 2, 3, 4, 5, 6. From point A, we stretched it to point B, which is 10 centimeters. From point A to point B. From 0 to 10 centimeters. As compared to stretching it further, 1, 2, 3, 4, 5, 6. So let's assume that this is point C, which is 20 centimeter point. The difference between the B to C is the same. It is also 10 centimeters. Okay, so as you could see, it is almost the same distance, 0 to 10. From 0 to 10, 10 to 20. So meaning, the stretching will be the same. So ang tanong dito, parehas ba yung energy na ginamit? Kung in-stretch natin from 0 to 10 muna, tapos in-stretch pa natin siya from 10 to 20, parehas ba yung energy yung ginagamit niya? So ang tinatanong dyan is the mechanical energy from point A to B, is it equal to the mechanical energy from B to C? Okay. So, ano ba mechanical energy natin from A to B? Mechanical energy natin kay A to B is yung elastic potential energy. B to C, it is almost the same, elastic potential energy. But the question is here, pag eto bang point B ang spring, nirelease natin dito sa pabalik sa A. Pag si C ang nirelease natin, where would it return back? Would it return back to B? No, it won't. It will go back to its original position C. So meaning, the stretching goes back to A. Okay? So meaning that the total mechanical energy from B to Z is not just from B to Z. Kasama niya yung from A to C. B to C is just part from the mechanical energy from A to Z. So yun ang kailangan natin makita. Ano yung mechanical energy niya from A to C? Okay? Yan, question mark. So to solve that, yun nga, gagamit natin, aalamin natin ano yung mechanical energy niya from A to B at kumpara natin sa mechanical energy niya from A to C. So, the mechanical energy from A to C is the mechanical energy from A to C, from B to C rather. The mechanical energy from B to C is the same mechanical energy from A to C minus the mechanical energy from A to B. Ulitin ko. The mechanical energy from B to C is equal to the mechanical energy from A to C minus the mechanical energy from A to B. Okay? So, tatanggalin natin mechanical energy from A to B para makuha natin, para makuha natin mechanical energy na ginamit from B to C. Okay? Kasi wala namang B to C lang agad. Kasi may stretching, hindi naman babalik sa uri, may stretching na siya. Kumbaga, may potential energy na siya at point B. So, ang tanong lang is pagka in-stretch natin siya. So, kailangan matanggal natin potential energy niya point B, yun ay consider natin 0 point. Para makuha natin ano mechanical energy na meron from B, in-stretch natin to point C. Okay, that's how we solve this. Now, to solve this, wala tayong K, yung spring constant. We don't know the spring constant. We could assume, yes, but let's try to utilize what we have. Okay, so ang alam lang natin is yung meron tayong mga K, meron tayong mga X. Okay. So meron tayong X which is here from A to B is 10 cm. The X from A to B is 10 cm. The X from B to C is also 10 cm. Okay, so ba't ganyan? Parehas din naman siya. Okay? Parehas siyang 10 cm. But, as I told you, hindi parehas yan kasi it is an additional stretching. Okay? So, dito tayo babagsak dito. So, let's try to analyze this. Okay? And try to point out the relationship between the two. Okay. So, ang hinanap natin is the mechanical energy from B to C at relationship niya sa mechanical energy mechanical energy from B to C at kumpara natin mechanical energy from A to B. So, the mechanical energy from B to C, that's the mechanical energy from A to C minus the mechanical energy from A to B divided by the mechanical energy from A to B. Mechanical energy from A to C, that is 1/2 K X from A to C squared minus 1/2 K X from A to B squared divided by 1/2 K X from A to B squared. Now to solve this, 1/2 KX, this would be, we could factor out 1/2 K, which will give us X from A to C squared minus X from A to B squared divided by 1/2 K from X from A to B squared. So, yung 1/2 will be cancelled, K will also be cancelled. So, the relationship between the two mechanical energies is XAC squared minus XAB squared all over XAB squared. So this would be XAC. This is x from A to C is 0 to 10, then 10 to 20. So this is 20 centimeter quantity squared minus x from A to B, that is 10 centimeter quantity squared divided by x from A to B. So once again 10 centimeter squared. So this is 400 centimeter squared minus 100 divided by 100. So this is 400 centimeter squared minus 100 centimeter squared divided by 100 centimeter squared. So it will be equal to 400 minus 100 is 300 divided by 100, it's 3. Okay, so furthermore, the mechanical energy from B to C divided by the mechanical energy from A to B is equal to 3, or the total mechanical energy from B to C is equal to 3 times the mechanical energy from A to B. So if you stretch it further, magdadagdag ka ng 3 times ng mechanical energy. So kung gumamit ka ng, let's say, 100 joules, okay, if in stretching, if the mechanical energy from A to B, this is just an example, nakagamit ka na 100 joules pag stretch nyo from 0 to 10 centimeter. Pag in-stretch mo pa siya, gagamit ka pa ng additional mechanical energy from B to Z. It would be 3 times the mechanical energy from A to B, or that is 100 times 3. So gagamit ka ng additional 300 joules. So ito yung sagot. So the answer is yes, it requires 3 times more energy. Okay, so we move on to question number 3. A water slide has a height of 4 meters. The people coming down the slide shoot out horizontally at the bottom, which is 1.5 meters above the water in the pool. If a person starts at rest and then slides down, how far from directly below the bottom of the slide does the person land? Neglect frictional losses from the slide. So the problem here is it starts from the top, which is 4 meters above the ground. So this is up from the bottom of the slide rather. So take note, it is 4 meters from the bottom of the slide. So we should assume this to be the 0 mark. And at the bottom of the slide, the slider shoots out horizontally and drops a certain height, 1.5 meters, before reaching the bottom of the water below. So from the slide, that the person sliding would shoot out horizontally, and dito magbabago yung problem natin, because here it is the changing energy from point A to point B, but from point B it is free from the slide. So meaning, and what we require is the distance from the below the slide to the point where it will fall down. So if there is a velocity here, which is velocity along the x, because this is already horizontal, meaning the person sliding will shoot out horizontally, but it will be starting to be affected by gravity, and its path will be like this. Its path will be just like projectile motion. Actually, this projectile motion too, because this is half. This is not from the same point. Okay? Nasimula na siya, nasa taas na siya, pabagsak na. So, we think kailangan natin, ano yung range na? What is the range from the point of release from the slide to the point where the person sliding will hit the water? So, let's part that at point C. So, this is a two-part problem. So, the given within the problem, the given are, of course, yung height 1, which is 4 meters. Height number 2, which is 1.5 meters. And, of course, gravitational acceleration, which is 9.8 meters per second squared. So, the required, the range. What is the range of the system? So, the equation that we will be using, since this is a two-part problem, so this will require at least two equations. The first equation is, of course, this is a work energy problem. So, the work done on the system should be equal to the change in mechanical energy. The second one is, since the point B to C is projectile motion, so we need to get the range, which is the range is equal to Vx multiplied by the time, the total time in the air. But we do not know. The Vx we can solve by the first equation. But the time cannot. We cannot solve that easily. We need to solve it through kinematics. So the equation for that is of course free fall. When if you recall projectile motion, the total time in the air, since this is just half the path going down, we will utilize the equation height is equal to VIT plus 1/2 GT squared. But of course, wala naman tayong initial velocity along the y, so this one is 0. So this just height is equal to 1/2 GT squared, or time is equal to the square root of 2h all over g. So these are the three equations that we will use. Equation 1, equation 2, and equation 3. Of course, equation 2 and equation 3 we can combine. Okay, let's try to solve first equation 1. So equation 1, the work energy equation, the work done on the system, but since there is no loss to frictional loss, there is no loss to friction, wala ding ibang force that acted on the system, so the work done on the system is 0, which is equal to the change in energy, or that is the change in gravitational potential energy plus the change in kinetic energy. So the change gravitational potential energy, mass times gravity times height initial, okay, height 1 minus mass times gravity. Oh, this is height height final. This is height initial plus 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. We don't have final height because we consider this to be the 0 point. So, final height is 0. Wala din tayong initial height. So, initial velocity. So, initial velocity is 0. So this is equal to 0. So this one, we start first with the positive, so this is 1/2 mvf squared minus mghi equal to 0. So both of them have masses, and this is equal to 0. So importante ito, equal to 0. I could divide everything by mass, which will cancel the masses. That will give me vf squared over 2 equal to ghi, or vf is equal to the square root of 2 ghi. So vf is equal to the square root of 2 times 9.8 times the height of 4 meters. So we have final velocity equal to 8.85 meter per second, which is also our Vx. Now from that, we could solve for our range. So the range, we could combine equation 2 and equation 3. So remember, equation 2, range is equal to Vx times time. And equation 3, we have time is equal to the square root of 2h over g. So we could combine them, change time here, use the time here, and use it here on this time here. So the range would be equal to Vx multiplied by the square root of 2h over g. So that is equal to Vx is 8.85 meters per second times the square root of 2h, so that is 2 times the height. So the height here is h sub 2, which is 1.5 meters, divided by gravity, which is 9.8 meters per second squared. So the range, if we try to compute that, the range would be approximately 4.9 meters. So this is the distance from the release from the slide, from directly below the slide, to the point where the person will hit the water. So magta-travel pa siya ng 4.9 meters in the air. Okay, so we move on to problem number 4. A hiker plans to swing on a rope across a ravine that is 1.8 meters wide and to drop when she is just above the far edge. At what horizontal speed must she start to swing? So the hiker plans to swing over the ravine, and at the point just across the ravine, she would let go of the vine, and hopefully what she plans to do is to fall straight down. That is what she plans to achieve. So we will not take into consideration the path that she might take pagka bumitaw na siya sa vine or sa rope. Na pwede kasing pagka galing niya dito sa point B, pwedeng humagis pa siya kasi magpo-projectile motion pa yan. But hopefully what she plans is to drop straight down upon reaching this point. So yun yung plano niya. Okay, so what she needs to do is to have a certain velocity. So yung kailangan niya, ano yung velocity niya to reach the other edge of the ravine with the rope to have a length of 4 meters. Okay, now so the question here is, what is the kinetic energy needed? Kasi yung velocity would mean meron siyang kinetic energy. So at point A, she has a kinetic energy, and at point B, that kinetic energy will be transformed to gravitational potential energy. So that is needed. How fast must she run to be able to sustain a certain amount of length that will allow her to reach this point? So ito yung kailangan niyang height. So ito yung kailangan niyang ma-attain na height, which is yung gravitational potential energy. Okay, now this one requires a little trigonometry to solve. We don't know theta here. We don't know this theta here or that angle here. But what we do know is that the length of the ravine, which is 1.8, is the same length here. So this one would be 1.8 meters. This length here, of course, it's the same rope. So this would also be the same length here, which is 4 meters. Now, to solve this, we need this x here because the height, which is this height, is the length of the rope minus the length x. So the height is equal to the length of the rope minus x. But we don't know x yet. But looking at our diagram, you can see that we have formed a certain right triangle. So if that is a right triangle, we could use Pythagorean theorem since we know two sides, the hypotenuse, which is the longest side, and one of the sides, which is 1.8 meters. So we could solve for x. X is equal to the square root of length squared minus the distance of the ravine. So that is b squared, the distance of the ravine. Ito yung d na yan, the distance. So by Pythagorean theorem, L squared, from here, L squared is equal to x squared plus d squared from this triangle here. And of course, from that, we could derive this formula, x is equal to the square root of L squared minus d squared. So we could solve for x. So this one is x is equal to the square root of L squared, which is 4 meters squared, minus the distance of 1.8 meters squared. So if we put that in our calculator, x would have a value of approximately 3.57 meters. So x is 3.57 meters. The height would be equal to the length minus 3.57. So that is 4 minus 3.57. That means the height of the hiker would be 4 minus 3.57, or that is 0.43 meters. So now we know the height that the hike will reach. So kailangan na lang natin mahanap is the velocity, which will come from the kinetic energy. So the second part, we use the work energy equation. So the work done on the system is equal to the change in gravitational potential energy plus the change in kinetic energy, kasi may nagbagong velocity. And since wala namang work done on the system, this would be equal to 0. Wala namang friction. Okay? So, or wala naman nagtulak sa babae. So, that's just gravitational to and kinetic. So, gravitational potential energy, that is mass times gravity times final height minus mass times gravity times initial height plus 1/2 mass times final velocity squared minus 1/2 times mass times initial velocity squared. So the final height, it is at point B, yung pinaka point, from point A to point B. So point B ang final height. Meron tayong height, which is 0.43. Initial height, ito yung 0 point natin. This is the starting height. So wala tayong initial height. 0. Final velocity, what's the final velocity here? At final velocity is the velocity at point B. Kinetic energy to gravitational. At this point, since minimum velocity ang kailangan natin, we could assume that all of the kinetic energy is converted to gravitational potential energy. So that means that dito wala na kinetic energy. So wala tayong final velocity. This would also be equal to 0. Of course, may initial velocity tayo. Ang velocity niya at the start of the swing. So rewriting, we have mass times gravity times final height minus 1/2 mass times velocity times mass times initial velocity squared equal to 0. So once again, equal to 0, we could divide everything by mass, which in turn will cancel all of the masses. Kasi equal sa 0 siya. 0 times 1 over m, 0 pa rin. So pwede tayo mag-cancel. Which will give us gravity times final height minus 1/2 times initial velocity squared equal to 0. Now, rearranging, lipat natin velocity, gravity times final height equal to 1/2 initial velocity squared, and we are changing the position of all the variables. We have 1/2 initial velocity squared equal to gravity times final velocity, multiplying both sides by 2. We have initial velocity squared equal to 2GHF, and of course, kailangan matanggal si square, we need to get the square root. So the square root of both sides will cancel the square here, so we have the square root of 2GHF. So the initial velocity VI would be equal to the square root of 2 times g, which is 9.8 meters per second square, times height, so that is 0.43 meters. So the initial velocity would be 2 times 9.8, that would be approximately 2.9 meters per second. So that is the initial velocity. So let's answer the question number 4. Okay, so thank you very much. After this, I will be posting 2 worded problems that you will need to submit in PBL. Okay, thank you very much for attending our class, for listening to me, and see you next meeting for additional lessons. So thank you.